And they look at me and I look at them and we smile. And they very expectantly. And then I come out with a statement, I wrote this down. I've got the finest notion what you want. Or how is that person going to respond? What would you say if you were that person? You'd say, you're wasting my time. Why didn't you tell me that over the phone? Okay, so they're going to walk out. I will not get to work. So what do they expect of me? What do they expect of me? They expect me to say, I thought about this. And there are questions that I have, but here's my understanding. You build what's called a straw man. A straw man is your view of what it should be. And then they go ahead and they say, well, there's something to it, but I don't think that, and maybe that, and that's okay, and so on and so forth. And the straw man serves as your first iteration for what this project is going to produce. It's critically important. Why is it important? Number one, you prove that you have the capability of using your minds to think of things where you have incomplete information. Okay, this isn't adding 1 and 1 and getting 2. It's using your imagination. You have to assume certain things. Number one, this person represents a serious project. You don't have laboratories in physics and 137 researchers. That's serious. Number two, when you're thinking that, you say, maybe this person, him or herself, doesn't know exactly what they want. So it's my job to help them to learn, and as a result for me to learn how we can work together to develop a project. Is this clear? Yes. So I cannot survive this second interview by saying, gee, explain to me again. It's not going to work because in that world, you don't get a second chance very much. You miss the first chance, it doesn't happen again. And he tells everybody else that it won't happen. So, I think to myself, they want so how could you make, is this a hard problem? Yes. Finding that integral. Technically, first level. No. Is it hard? Not at all. No. I can say, well, all it is ax cubed plus 3 plus bx squared over 2 plus cx evaluated at b minus the value at a in the model. Now, the first thing I think of after that is I have a set of order, I have an order of thinking. First thing I say, for this software, what is the problem? Can I say, here's a problem, and the problem is clear. What's the problem? Find the integral. Okay? I know that there's a certain criteria. Is this problem necessarily well posed?
Yes.
No. Is it well posed? What are the conditions for well posedness? The interval's got to exist. Am I right? What was well posedness? Respond. There's an old comedy, I forget who did it, an ancient film. Somebody says, go up those stairs, but there's some specificity in between, in case it was pulled down. Okay? What is well posedness? Well posedness means, firstly, crudely, that the problem makes sense. As a problem that I want to solve, that it makes sense. When does a problem make sense? When you have a solution, when a solution exists, when that solution is unique, and when that solution depends continuously on the data. Okay? So, mathematically, purely mathematically, here's an integral. Does that integral exist? Tell me. Sure it does. I can write it down. I can write down a formula with a final value. Okay? But now I think to myself, well, let's kind of think a little bit from another point of view. I think the software invariance. What is the meaning of the software invariance? Remember this term. Somebody says, never saw it in my life, it's on page 8 in the text. Okay? Goodbye. What is the software?